Guys. Okay, let's look at learning target number 2. So we talked about vectors and how they have both magnitude and direction, and then we also talked about how we can add vectors and end with a resultant. Okay. Now let's go a little bit further into that mathematically. So here we have this vector A, and vector A can be broken up into its x and y components. Okay. And from there, we can also determine the angle, and it depends on what values you have that you're working with there. So you either know your x and y, and you can figure out your resultant and then your angle, or you know your resultant and the angle, and then you can figure out x and y. Okay. So yep, we're dealing with triangles, so we're going to be doing trig. Okay. So we'll be working with our sine, cosine, and tangent. Right. First example here. Find the x and y component for the following vectors. Step 1, draw a picture of the scenario. Step 2, identify the vector. Okay, so our first one is a vector is 9 meters long at 35 degrees. So we have 9 meters long at 35 degrees. Okay. And so I like to label it or name it, like we can call this just vector V, and we know that the magnitude of this vector is 9 meters. Okay, so I drew a picture of the scenario, and now I'm going to identify the vectors. Let's see if we can focus a little better. Okay. So we need to break it up into its x and y components. Okay, so let's draw those in. This one would be v sub x, and then we have v sub y. Okay, because x plus y would result in this vector here. So we have our right triangle, and we know the angle, and we know the hypotenuse. Good thing to remember, you have your TOA, right? So the sine of this angle is going to equal the opposite over the hypotenuse. Okay, so let's put that in. The sine of 35 is going to equal v sub y over 9.0 meters. And then we just want to get v sub y by itself, so we'll multiply both sides by 9 meters. So 9 meters sine 35 will equal v sub y. I'm going to plug that in my calculator. Now when you plug it in your calculator, make sure that you are in degrees and not radians. Okay? So we're going to take 9 times by the sine of 35. And I end with, so let's see, v sub y 5.16219. Now let's look at sig figs. We have two significant figures, so our final answer will be in 2 sig figs. So we'll round that 1 up to a 2 because of the digit 6 after it. And then this is just a component, and so we know that our units are meters. And when we look at this here, sine 35, that doesn't have a unit attached to it. The only unit we have is meters. Okay, now for our x component, we want to be adjacent. Okay, so we're going to use cosine now. And similar to before, so I'm trying to decide where to write this. Similar to before, cosine of 35 is going to equal adjacent, which is v sub x, over our hypotenuse, which is 9 meters, times both sides by 9. So 9 meters times by cosine 35 will tell us v sub x. Okay. Plug it in the calculator. I get 7.37237. I have 2 sig figs, so I'm going to round that to 7.4 meters. All right, so there's the x and y component of that vector. Okay. Now, a soccer ball is kicked at a 20-degree angle and has 125 newtons of force. So we have a 20-degree angle, okay, and our vector component here, let's call it a force vector, is going to have the magnitude of 125 newtons, and it has an angle of 20 degrees. Okay, so when I'm looking at this, I want to see where my x and y components are in relation to the resultant and using the trig functions just as before. Like, the only difference here is that we've now given it a name and we've said that this is a soccer ball and it's being kicked with a force, and the vector for that force is 125 newtons, 20 degrees above the x-axis. So again, I can draw in my f sub x and my f sub y. Okay. And back to cosine and all this stuff. So the sine of 20 is going to equal opposite, which is f sub y, divided by the hypotenuse, which is 125 newtons. So times both sides by the 125. Sine 20 is going to equal f sub y. Okay. And so plug that in the calculator. Okay, and I'm getting an answer of 42.7525, but what about sig figs? First thing, I've dropped a digit, and I shouldn't have. Let's pull that back in, because that reduces our precision. So we had 20.0. Remember, zeros after, no, trailing zeros. If there is a decimal within the number, they're significant. So we have 3 sig figs and 3 sig figs. So my final answer will have 3 sig figs. And then my units are newtons. There's f sub y. Okay. Now, for our x component, cosine of 20 is equal to f sub x over 125 newtons. So 125 cosine 20 is going to give me f sub x. And I get 1, I dropped my digit again. That is 20.0. Okay, so 3 sig figs, 3 sig figs. My final answer is 117.462. So I'm going to round that to 3 significant figures. Units of newtons. Okay, now notice that we have sine is working with y and cosine is working with x, and that repeated here. That's not always the case. Okay, so it's very, very important that you always draw out the image so you don't just assume that's happening. And that's what you're going to see in example 3. So on the next video, we'll start right here, where we'll notice that we're not always sine related to y and cosine related to x. Okay, guys, keep up the hard work. We'll look at number 3 in the next video.